Hello, everyone. Welcome to Getting Started with Blackfire. Blackfire is a performance management tool that helps solve a problem with slow pages. As one of the stats that's widely known, 53% of users will abandon websites that take too long to load, especially if it takes more than 3 seconds. Solving this problem is something that's quite important to businesses since you don't want to be losing over half of your traffic. So fixing this problem can happen in any place. You could fix it in production if you like, but it'll be a lot more expensive than if you were trying to fix it in development. Profiling itself is a way to look at how to running. So Blackfire, its job is to tell you the amount of time that certain function calls are spending and how much the application itself overall is spending on various aspects, including I/O wait time, CPU time, and wall time. And wall time, of course, is a combination of I/O time and CPU time together. Blackfire is also able to show you how much memory each function is consuming, how much network traffic is being used, and the number of HTTP queries and SQL queries that are happening. A lot of people like to look at Blackfire as an application performance management tool. This is somewhat true, but Blackfire differs from traditional application performance management tools in several ways. One is that its focus is on PHP code. Blackfire is very good at understanding PHP applications. It knows what PHP applications do, and it knows how to best look at how they're performing. Also, unlike most application performance management tools, Blackfire provides no overhead to end users. If a profile is not being created at that specific request, Blackfire provides no overhead. Basically looks to see, is this request supposed to be profiled? If it's not, then it doesn't do anything at all. If you're used to tools like Xdebug, Xdebug uses system resources even if it's disabled. So just by having it installed, Xdebug takes resources. That's not the way that Blackfire works. We also find that Blackfire can be very complementary to application performance management tools. For example, if you're using New Relic will look at every single request that comes in to try and figure out what sort of resources are being used. We could use New Relic integration to notify Blackfire to create when certain alert conditions are raised. So we can use the we can be complementary to these different services so that when they look at certain resource levels, CPU utilization, memory utilization, whatnot, they can actually trigger builds in Blackfire so that you can look more deeply at your application during the time that those conditions are happening. We also like to think that Blackfire should be used in all stages of development, starting with development. We can actually do debugging, improving, and validating code before your code is even pushed to testing or staging. But once it's in testing and staging, it can be checked again as well against the rest of the system that against the rest of the code that's being put into staging. And once it's in production, since it's safe to be used in production as well, you can use that to do regular builds or periodic builds to make sure that the system is still running. You can use it to try and find issues that are happening in production, rather than having to patch the server to test something right now in production. If Blackfire is always installed, it's easy to just go ahead and run a profile right then and there. How Blackfire works, it's actually comprised of 4 pieces. The probe is the piece that most people are probably interested in. It's actually implemented as a PHP extension. Its job is to actually look at the code that's being executed when a profile is being requested and store all of that information. There's also a piece called the agent. The agent actually lives outside PHP, so that PHP, the probe can offload the raw data as quickly as it can so that it doesn't have as big of performance impact on other requests. And then the agent is responsible for uploading it to the Blackfire servers. The other piece that most people are going to be interacting with on a regular basis would be the companion. In this case, it's either something like our browser extension or a command line application. It's the thing that actually tells the probe that, hey, this request or this execution needs to be profiled. Blackfire is easy to install. We provide packages for many platforms, probably most of the platforms that many of you are going to be using. The installation is very quick. I'll give you a pointer to the documentation for the install in a few minutes. And again, this can be installed in in your local dev environments. It can be installed on your test machines, your staging environments, QA environments, anything along those lines. And it can also be safely installed in production. So now we're going to take a quick check to actually see how to do a profile with Blackfire. And to do that, we're going to switch out into the browser. And this is the Blackfire dashboard. So if you already have your Blackfire accounts up and running, you should be able to see a dashboard here. We have My Environment, which should be the default environment that everybody has. This is a free environment that can be used by anybody. But you may also end up having additional environments that can have different configurations and different support levels. It's really easy to get to the documentation from the Blackfire dashboard. So we'll take a look at this real quick. Go into the docs. If we want to know how to install, for example, you can click on the installation documentation. And we have installation instructions for many different services. So Debian, Red Hat, Mac OS, Windows. And the documentation is going to include all of the steps that you need to install everything. So we can install, if you need to configure something like a Debian repository, which is the thing that runs in the background, we're actually able to see here that an agent has been detected, so the docs will actually try to help you if you already have something installed. It tells you how to install the Blackfire command line tool. This is the tool that you can use to profile command line applications or command line processes, queue workers, cron jobs, that sort of thing. And then information on installing the probe itself. So this is the thing that will actually configure PHP for you. So the docs have a lot of information in them, including information on writing tests, writing scenarios. These can be quite interesting things to check out, including metrics, and then information for all of the integrations we support. So if you're looking for integrating Blackfire into some of these environments, check these out, as these will have most of the information that you're looking for. So we're going to head back to the dashboard, and we're going to take a look at one of our we're going to take a look at a profile. First thing, I'm going to go to the Blackfire demo. And this is one of our collaborative environments. As you can see, several people have actually created profiles in this environment. And how to create a profile using the Chrome extension is pretty easy. So I'm going to switch over to an application that's been deployed called GitList. GitList is a PHP application that is set up to be a standalone Git repository browser. So you can see all of the tags, all of the versions, and you can go into directories to see what the code is going to look like. You can actually click into the code to see what it looks like. So we're going to look at this application here. Since it's a PHP application, and we're going to try and do a performance fix for this, or see if there's any sort of performance things that we can do. So we're going to click the Blackfire companion, and then we're going to make sure and choose the correct environment. In this case, we need to go into the Blackfire environment. We're going to choose no reference. Reference profiles are sort of like tags. So you can create a reference if you like, and then later you can choose additional profiles to go to those existing references. But for this example, we're just going to choose no reference. This means just create a standard profile for this environment. So we'll do no reference. Disable aggregation is a tool to disable a feature of Blackfire. Blackfire will make 10 requests for every profile that you create, and then the profile is actually an average of those, is a representation of the average of those 10. Disable aggregation, it's actually only going to make one request. This is useful if pages are already taking a long time. If you have a page that takes 10 seconds to load, for example, if you don't disable aggregation, that's going to take 100 seconds before the profile can actually be ready. And also if the page that you're profiling has some sort of side effects, maybe some sort of counter or increment on that page, you might not want to have 10 go up just because of the request or just because of the profile. So in those cases, you might want to disable the aggregation as well. But I'm going to uncheck this now and have the default behavior happen. Click Profile. And what we'll see is the Blackfire bar at the top of the screen, and you'll see the progress. So each 10% represents one of the profiles that we are creating for the average. It's going to aggregate the data and then provide some high-level stats. So we see wall time, we see I/O wait time, CPU time, memory, HTTP requests, and SQL queries. We're not doing any HTTP requests or SQL queries, so these values are going to be empty. So from here, I can click into the profile to get into the profile view of Blackfire. And this is broken down into two separate sections. We have the function list on the left, and we have the call graph on the right. The function list on the left is sorted by exclusive time. Blackfire has this concept of exclusive versus inclusive time. So for example, this read and write call has exclusive time of 5.93 milliseconds, and the inclusive time is 49.3 milliseconds. That means that this function call itself took 5.93 milliseconds, but then it also made calls to additional functions that contributed another 44 or so additional milliseconds of time. And we can see that by clicking in here. If you actually click on the function, you can see some more detail. So we can see that overall is 49 milliseconds, 44 milliseconds of that was I/O wait, and 5.23 milliseconds was CPU time. We can also see the callers and the things that we called ourselves. So this is where we'll see that another 41 milliseconds of time was called from within the read and write call. So you can get an idea of more of what's happening by clicking in and zooming in on these different environments. So we look at fread now. Fread was 1.61 milliseconds, and stream select was 41.7 milliseconds. So those two combined should be around the 44 milliseconds that make up the difference between the inclusive and exclusive time. We can collapse those, and then we can look at the call graph. The call graph, we try to limit the number of functions that are called to just the things that are sort of low-hanging fruit as far as performance is concerned. So we'll see kind of a critical path outlined in red showing the path to the things that are high on the list. So if we hover over this light pink box, you'll see that proc open on the function call list is highlighted. If we go to the dark pink box, it's stream select. So we try to give you the path to the code that could potentially be giving you the most amount of time. The call graph can be zoomed in so that you can get a better idea of what's going on. And you can also zoom in with the magnifying glass to get even more detail, which will expose additional calls that might have been hidden before. So even though we limit the number of calls that people see, we do have the ability to give you more detail once you get to a specific function call. We unlock the extra calls that we were hiding before once you zoom in. So that's with the little magnifying glass on each specific thing. Clicking on this display mode icon will switch you back to the default view. So this is the total time view. We can also switch to I/O wait view, and as you'll notice, the call graph changes slightly and the function list changes slightly. So this is all now geared around the perspective of I/O wait. If we click the CPU time, you'll see that the call graph again changes considerably, and you'll notice that the function calls that are on the top are no longer the same function calls. If we look at I/O wait, we see stream select and proc open, but on CPU, we're going to see some calls CPU intensive rather than I/O wait intensive. Clicking in the memory view switches the perspective to be just focused on things that are using a lot of memory. So we can see this call tree coming this way is sort of the path to some of the bigger things, and then we can look at fread and string to string here on this path. But we also have autoload class map and composer autoload include file as things that are taking up a lot of memory as well. These other views will also switch around depending on the perspective of network traffic. We also have a view of HTTP requests that you can see with if you're making API requests to different services, they'll show up here. We'll see the combination of I/O wait and network traffic that was associated with those calls and the number of times that they were called. And similarly, we also have a SQL query view where we can see specific SQL queries without bind data. We have I/O wait time, and then we have the number of calls that are made on those. So this is the general view. We also have some other tabs as well. We have recommendations, which pop up based on community feedback and our own idea of best practices. We're able to see things like process count 20. You know, we're recommending that you don't do more than 0 sub-processes in production. But in this case, it doesn't necessarily mean anything for us because we have to call out to the Git binary for this application. And so we can click into the question mark, and we'll usually give a reason as to why we think that certain things should be done or not done. And then we usually try to provide a solution. So rather than calling out to the system directly, we're suggesting maybe you use a message broker or build some sort of queue system. But you can also use the notes here to change the recommendation so that you can say, I want it to be less than 10, for example. Maybe you know that you need to do processes on this, so you want to set up the rules to something different, so you want to do less than 10. Those show up on the assertions. These are things that you actually get to write. So here's an example of us writing an assertion to say that we really wanted to do less than 10 process calls, but we did 20. So this assertion in this test is going to fail. But we'd also said that we wanted to make sure that the wall time for any processes executed was less than 30 milliseconds. And in this case, it was 21. So this one was good. So the process call related assertions, we decided what we wanted our threshold to be. And we were able to then see when we failed on one of them because we ended up doing more process calls than we wanted. We also have a few others, like all pages are fast. We have some twig specific things, and then we wanted to make sure that we aren't dispatching too many Symfony events. And again, these are things that can be found within the documentation. And if you want to look at that, you can look at the writing tests. Talks about how to build these things into your Blackfire YAML file. So this is the only file that needs to be added to your project. And this only needs to be done if you want to write your own assertions or write your own scenarios. So you don't need to add this to your application, but if you do, it can unlock some very cool features within Blackfire itself. Walking through a profile, we can look at this and say, okay, stream select is sort of the biggest thing. It's called almost 80 times. So this is a 79.5 calls isn't something that's possible, but this is because we're doing an average here. So on average, it's being called 79.5 times, but really it's close to 80. So we're looking at it and we want to zoom in. So we can click on the zoom in and say, we can't do anything with this because stream select's a PHP call. So we can walk up the tree to try and find some things that we think might actually make this better. So right now we're looking at a bunch of process calls. We don't really want to mess with the process component. Just above this now, we're going to look at getting into the getter client. So this is one of our dependencies, and it looks like we're calling get version 10 times. We're not exactly sure why it's being called 10 times, but this might be a good case for being able to do refactoring. So we can look and say, all right, we don't want to do anything down here, but if we can limit the number of times that get version is called, get version itself is taking up almost 30% of this application's execution time. So we're going to quickly look at a fix that's deployed to try and refactor how get version is done. So we bring up git list again. We're going to do another profile, and we're going to generate this profile. And what we can look at here is before it was about 126 milliseconds on the original version, and now it's down to 101. So we know that we've made some sort of improvement, but we don't really know all the details. So we're going to go ahead and click into the profile and just get a general idea of what's going on here. We see stream select is called 44 times, and previously it had been called 80 times. So we managed to bring down the number of times stream select is called by almost half, which is great. So we can go through here and actually try to figure this out on our own, but we can actually put Blackfire to use to help us with this. So we can choose to profile from the version that we made 9 minutes ago to the new one. And it's going to shift us into a view that's called diff view. So rather than showing total times on things, we're actually showing differences. So for the IO wait, or for the total time, we see that it went from 126 milliseconds to 101 milliseconds, which was a saving times of overall of 20%. IO wait time went down considerably as well, 23%, and CPU time was reduced by 15%. So it went from 55 to 47. So we can actually shift views to these different perspectives as well. So you can kind of get an idea of what's going on here. So if we look now at this call graph on the main time, we'll see at the bottom we have stream select. We can look and see that stream select specifically was called less times, from 41.7 to 27 milliseconds, which is great. And we can zoom in now and kind of walk up to see what we were looking at before. So overall, we've decreased time in a lot of these places, and it looks like get version now is taking 32 milliseconds less time. But we'll see that the calls from run to process run increased by a bit. So overall, things are faster, but we did actually decrease performance in at least one other area. So if we zoom in on get version now, we can look at get version on the left-hand side. We can click into this and see what we managed to save. So we were able to save a considerable amount of time. Get version is called 87% less time than it was before. So this would be a successful refactoring based on doing a diff between a profile before, where things were kind of slow, and then refactoring it to make some changes and make it a little bit faster, and being able to look and see exactly what impact we've had on our application. Let's see here. So that's the general idea of how to profile your code with Blackfire. Again, the docs are easy to find from the Blackfire dashboard, but it's also easy enough just to go to /docs. This has a lot of information both on setting up Blackfire along with being able to use it. And we also have a book available online called 24 Days of Blackfire. This gives you a nice walkthrough of most of the features of Blackfire from the perspective of looking at a new feature or a new functionality each day. And yeah, so I think we have time for questions. Let's see here, we have a question to how does Blackfire deal with the front-end stack with things like JavaScript? And the question was, does it completely ignore that? And the question is yes. Blackfire focuses specifically on PHP code. So if we look at the stats, like the 3-second load time that we want to avoid, you know, some of that is contributed to the actual backend, and some of that's contributed to loading front-end assets. So Blackfire is specifically geared toward PHP, and it can help make PHP code very fast, but it isn't going to be able to help you on the front-end stuff. So you can't rely to get you all of your performance increases. There's another question. I don't really get the percent things. It doesn't add 100%. What does it point at? Let me see here. I'm going to go back to the, here we go. So the percentages, I'm not sure if these are the percentages that we were talking, that this person was referring to, but what these percentages look like. All right, so it's not those percentages. I'm seeing the question came back as not those percentages. So okay, so these ones. All right, so the question is, what do these percentages look like? So what this means is that 33% of this application's runtime is dedicated to this function call. So this function call, stream select, is contributing to 33%. And if we expand stream select, what we see here is 41.7 milliseconds time spent on stream select. And if we look at the total being 126 milliseconds for the entire application, I think we should be able to do the math here and say 41.7 divided by 126. So that's 33%, so 33.22%. There must be some other value in here that it's using to be 33.22%, but that's what these percentages represent. So if you're looking at this from the perspective of these applications, higher up in the application, we'll see that 80% of the time of this application was spent inside this tree controller. If we scroll up higher, we'll see that the handle raw from HTTP kernel accounts for 84% of the execution time of this application. So as we go up all the way, we're going to end up at main, which includes 100% of the time. So it's going to include 100% of the time because it's the entry point in the application. But the smaller calls further down can start taking smaller amounts of time. So we see 11, 6, 6, 5. And if we get all the way down here, though, we're looking at things that start to continue to take a lot of time. So this process component, we're spending 55% of this application's time just running calls out to Git and waiting for the response, waiting for the results. So I hope that helps answer that question. If not, we can definitely answer that question if you want to go into more detail on the help or feedback side of Blackfire. Let's see here. Are there other questions that we have? Looks like there's a question about profiling additional types of applications. We don't have that ability now. Right now, we're exclusively focused on PHP, but it would be possible someday to potentially do other things. But that's something that isn't on the roadmap right now. Why is it not open source? Well, it's not open source. It is free to use, but it is not open source. Sensio Labs has been the people behind Blackfire have spent a lot of resources on this internally. I'm not exactly sure why it's not open source. It is, yeah. So I don't really know how to do that one. We do have various features of Blackfire that is open source, including the player. We do have the Blackfire player that is currently in alpha, I believe, that is something that we have open source. And many of the recommendations are open source as well, so that people can contribute to the recommendations. We have recommendations specific to different communities that people are helping build. Let me see if I can find some of these, like the metrics that we have. We have metrics that can be applied to different frameworks. So we have some Bolt information here. We have a bunch of things related to Doctrine, a bunch of metrics related to Drupal. So these are things to contribute to. It's stuff that Sensio Labs is building directly, but it's also something that we're getting input and help on from people in the community. The question is if there are any compatibility concerns regarding Magento with Blackfire. No, there aren't. We actually have some really good support for Magento. We have a Magento add-on that provides some of the metrics. So these are metrics that aren't available for everybody. It's actually a paid add-on to get access to these. And we're actually one of the 3 technology partners that are part of the Magento Cloud offering. So we do have a lot of support for Magento. There aren't any direct compatibility issues with that. And in fact, we don't actually have any compatibility issues with most of the frameworks. None of the PHP code actually needs to know about Blackfire. So we're able to profile any PHP application pretty easily. Does it integrate with GitLab if it is a hosted one? The answer to that is yes, provided your GitLab installation is somehow publicly accessible to the outside world. We do have a list of IP addresses that we can use if you want to whitelist IP addresses for coming into your GitLab instance. So yeah, so we should be able to integrate with that just fine. Question: if you have a CMS like WordPress or Typo 3, can I analyze my own extensions that I deployed without getting the core from the CMS? That is actually a good question. We do have the ability to look at we can search through function lists for specific things. So if we want to just focus on Twig, let's say your code is all within a certain namespace, you'd be able to specify the namespace and then look at just your code. But we don't have the ability to filter the call graph to get outside of the core. So you would still have the core around your application. hopefully that answers the question. Are there any other questions? All right, I think that's probably it for now then. If you have more questions, you can send us feedback from the feedback button inside Blackfire itself. This little feedback button should be here pretty much on every page. So this is a good way to get to us really easily. Oh, we have one more question. Can you get Blackfire hosted? Is this like an on-premise installation? If so, we do have the ability to do an on-premise for people as well. That's it's one of the enterprise features, or an add-on to the enterprise version of Blackfire. So it is possible if you have all of your code that needs to be inside your own firewalls or not hosted on certain cloud providers, we do have the ability to do self-hosted install. We've seen that for people in specific countries. We've seen it for people working within certain government agencies that need to have their code protected at all time and be very careful with the data that's being sent to other providers. So we do have the ability to get Blackfire installed in an on-premises solution. So yes, feel free to send us feedback. We also are offering our webinar attendees a discount if you'd like to upgrade to Profiler Premium. We're offering 30% off the first year of annual subscriptions for Profiler Premium. Yeah, so if there are no other questions, I think that's probably it for today. For another minute or so, just in case we have some last minute questions coming in. Otherwise, thank you very much. Good luck with Blackfire. And yeah, happy profiling.